Welcome, curious minds, to another deep dive.
Great to be here.
Today we're taking a really fascinating journey into the world of virtualization. Specifically, we're focusing on VMware vSphere.
That's right.
Our mission today is to extract the most important sort of nuggets of knowledge from a set of sources we've got. Excerpts from Navigating the VMware 2V0-16.25 exam, practice questions and explanations. Now, our sources are framed around that VMware 2V0-16.25 certification exam, which, is a pretty serious test for virtualization pros.
It is.
But our goal isn't just about passing a test.
No, definitely not.
We're really digging into the practical understanding of what these features actually do, and maybe more importantly, why they are so absolutely critical for managing, modern virtual environments.
Precisely. This deep dive, it isn't about rote memorization at all. It's really about understanding the practical applications.
Yeah.
And how all these powerful tools connect together, helping you grasp how virtual infrastructure is built to be, resilient, efficient, and frankly, pretty transformative for businesses.
Yeah.
We'll explore features that cover everything from, say, centralized management all the way to robust disaster recovery, giving you a clearer, more insightful picture.
Okay, mission laid out. So let's start with maybe the most basic challenge. You've got multiple physical servers, right? Yeah. Each maybe hosting dozens of virtual machines. How do you even begin to control all that complexity? What's the single pane of glass here?
Well, what's truly insightful about VMware vCenter Server isn't just that it centralizes management, which is huge, but it's how it transforms what would otherwise be, frankly, a chaotic collection of individual servers.
Right, just boxes everywhere.
Exactly. These ESXi hosts, the hypervisors running your VMs vCenter, turns them into a unified, intelligent data center. It's really the critical ingredient that unlocks all the advanced features we're going to talk about. It becomes the nervous system, allowing your whole virtual environment to think and react as one single thing. It's your command center.
The brain.
The brain, exactly. It enabling crucial stuff like distributed resource scheduler, that's for load balancing, high availability for failover, templates for quick deployment, resource pools.
Yeah.
All managed centrally.
That makes perfect sense. You really can't run a virtual empire without that central brain. Okay, but with all these VMs talking across different physical hosts, managing the network side of things must get incredibly complex too, right? How does vSphere simplify that web of virtual networking?
Yeah, that's a really common challenge administrators face, keeping network policies consistent when you have lots of hosts. And that's precisely where the distributed switch, or VDS, comes into play.
Yeah, yes, okay.
And its main purpose is to centralize and manage networking across multiple ESXi hosts, almost like they were one giant switch. So instead of configuring networking on each host one by one.
Which sounds like a nightmare.
It can be. With a VDS, you set up and manage policies, things like VLANs, security settings, traffic shaping cribgrid. You do all that from vCenter for the whole cluster.
Ah, okay, one place.
One place. It ensures consistency, dramatically simplifies the setup, and just makes managing the network much, much more streamlined for you. It's kind of like the difference between managing dozens of individual power strips versus having one smart power grid,
Got it. Okay, nice analogy. So we've got central control, consistent networking. Now let's talk about the nightmare scenario for any IT admin. A physical server just crashes unexpectedly. Yeah. My first thought is, oh no, all those VMs just went offline.
Yeah.
How does vSphere prepare for that? How does it minimize disruption when that happens?
That's a core concern, absolutely. And vSphere offers several layers of protection here. Our first line of defense is VMware vSphere HA. High availability.
HA.
Right. Its main function is pretty straightforward.
Yeah.
Automatically restart virtual machines on another healthy host if their original host fails.
Okay, so it notices the failure and just starts them up elsewhere.
Exactly. HA constantly monitors your ESXi hosts and the VMs on them. If a host goes down, it quickly detects that failure and initiates the recovery of the affected VMs on another active host in that cluster. Now, it's designed to minimize downtime, but it's important to understand it's about rapid recovery. It doesn't prevent a brief interruption. It just gets the VMs back online really quickly.
Okay, so it's like a rapid response team.
That's a good way to put it, ensuring cluster resiliency, getting things back fast.
Okay, HA sounds like a lifesaver. Gets you back up quickly after a host failure. But like you said, even a quick restart means a brief interruption. What about these applications where even, a few seconds of downtime is just unacceptable? Huge financial loss, compliance issues.
Right.
Is there like a no downtime ever option for those really critical VMs?
That's an excellent point. And you're right, HA is about fast recovery. For those apps demanding absolutely zero downtime, not even a millisecond, that's where vSphere fault tolerance, or FT, steps in.
FT.
Right.
Okay, different from HA.
Totally different approach. Our sources clarify its primary purpose, providing continuous availability by running a secondary live copy of a VM on a separate host.
A live copy, like running simultaneously.
Exactly.
Uh-huh.
Imagine a shadow VM running in perfect lockstep with the primary one. Every instruction, every memory change, it's mirrored instantly to the secondary.
Wow.
So if the primary host fails, the secondary VM is already running. It just takes over instantly. Virtually no downtime, no data loss. It's really quite remarkable for things like critical databases, maybe custom transaction systems, anything that absolutely cannot tolerate an interruption.
That sounds, yeah, almost too good to be true. Truly zero downtime. Is there a catch, a trade-off? I mean, is FT practical for every VM, or is it really for specific high-value cases?
You've hit on the crucial point there. It is incredibly powerful, but FT does involve, well, additional resource consumption. You're essentially running 2 copies of the VM, right? Double the memory, double the CPU cycles in a sense.
Ah, okay. Resource intensive.
It is. So it's typically reserved for your most mission-critical applications. Those where the cost of even a second of downtime is way higher than the cost of the extra resources.
Yeah.
It's probably not for your everyday web server, but yeah, invaluable for those bet-the-business applications.
Makes sense.
Now, thinking bigger. What if it's not just one host? What if an entire data center or, a whole site goes offline? Big power outage, flood, whatever. How do you recover from a complete site failure?
Exactly. That's the next level, isn't it? Business continuity, disaster recovery. A single host, even a cluster failing is one thing. Losing a whole site, that's a different beast. What's the vSphere answer for that kind of catastrophic event?
For that wider disaster recovery strategy, we turn to vSphere replication.
Okay, replication.
This feature provides asynchronous disaster recovery. Basically, it continuously copies VM data from your primary site to a secondary site. Could be across town, could be thousands of miles away.
Asynchronously, meaning not quite real-time like FT.
Correct. There's usually a small lag, configurable, called the recovery point objective, or RPO. It might be minutes, maybe longer, depending on your needs and bandwidth. But the key is, if your main site fails completely.
You can bring the VMs up at the other site?
Exactly. Those replicated VMs can be recovered at the target site with minimal data loss, typically just whatever changed since the last replication cycle. It's absolutely essential for a robust DR plan, giving businesses confidence they can survive major outages.
Right, okay, so we've covered keeping things running, keeping them available, even when hardware fails or whole sites go dark. But just running isn't always enough, right? We need efficiency, too. We don't want some servers just sitting there idle while others are, sweating under heavy load.
Absolutely.
How do we make sure all our valuable compute and memory resources are being used as smartly as possible across the whole environment?
That's precisely the problem vSphere Distributed Resource Scheduler, or DRS, is designed to solve.
DRS.
This feature dynamically balances workloads across multiple hosts, and it does it by intelligently migrating VMs automatically.
Automatically? How?
Well, DRS continuously monitors the resource usage across the cluster, CPU load, memory usage, that sort of thing. When it spots an imbalance, maybe one host is getting overloaded while another has spare capacity.
It steps in.
It steps in and proactively performs vMotion migrations. Now, vMotion itself is pretty amazing. That's VMware's tech for moving a running virtual machine from one physical server to another without any downtime or interruption at all.
Live migration. Still kind of blows my mind.
It really is impressive tech. And DRS uses vMotion to shuffle VMs between hosts, ensuring resources are used efficiently and performance stays optimal across the board. I mean, I remember the days before DRS, we'd literally be charting server loads on whiteboards, manually moving VMs around during maintenance windows.
It was frantic.
Haha, I can only imagine. Now it's like having an AI conductor for your whole server orchestra, making sure every instrument is balanced perfectly without ever dropping a note.
That's a fantastic evolution. No more whiteboard shuffling. Okay, speaking of resources, storage is always a huge one. Traditionally, enterprise shared storage meant big, expensive, dedicated hardware SANs, mass devices, often a totally separate system to manage. Has virtualization changed that whole approach?
Oh, absolutely. It's been a massive shift towards software-defined infrastructure. And the vSAN data store is a prime example of this.
vSAN.
Okay. Its unique function is essentially to aggregate the local disk drives inside your ESXi hosts.
The disks already in the servers?
Exactly. It pools those local disks together across the cluster and turns them into a single shared storage resource. a distributed data store.
Wow, so no need for that external SAN or NAS
Like
box.
many use cases, yeah. It can eliminate the need for that separate expensive storage hardware. It democratizes enterprise-grade shared storage by just leveraging the internal disks you likely already have in your servers.
That's huge.
It is. And it doesn't just simplify the architecture. vSAN also provides high availability, fault tolerance for storage, and scalability. Need more storage?
Yeah.
Just add more hosts with disks, or add more disks to existing hosts. It's really powerful leveraging existing resources in a new way.
That is a game changer, turning commodity hardware into powerful shared storage.
Okay, so beyond the core infrastructure stuff, managing a virtual environment involves lots of, repeatable tasks. Deploying new VMs, keeping systems updated, sometimes tedious stuff.
Very true.
How does vSphere help admins streamline those day-to-day operational challenges? Move beyond just reactive firefighting to more proactive, efficient management.
Yeah, this is where efficiency and consistency really pay off. Content libraries in vSphere are designed for exactly this.
Content library.
Yeah. Their purpose is very practical. Centrally store and share things like VM templates, ISO images, OVF files, basically, the building blocks you use to deploy new systems.
So like a shared repository. Exactly. It lets administrators manage all these common deployment assets across different vCenter environments, even across different sites, all from one consistent source. So no more, hey, where did I put that Windows Server ISO? Or is this the latest approved template? For every single deployment.
I can see how that saves time and prevents mistakes.
Absolutely. It significantly improves consistency, speeds up VM provisioning, saves countless hours, and definitely reduces errors.
Okay, no more hunting for templates or ISOs, big win. But beyond deploying new stuff, what about maintaining the existing systems? Patching, updating hosts, that can be a real headache, often needing planned downtime, right?
Yeah, that's always been a challenge. Patching cycles, maintenance windows.
How does vSphere tackle that?
Well, when we look at that bigger picture of ongoing maintenance and system health, we turn to vSphere Update Manager, which is now more broadly called Lifecycle Manager.
Okay, Lifecycle Manager.
This feature really helps automate the patching and upgrading processes for your ESXi hosts. And it also handles things like virtual machine hardware upgrades and VMware tools updates, all with minimal disruption.
How does it minimize disruption? Does it use that vMotion thing again?
Precisely. It integrates tightly with DRS and HA. So, for example, before Lifecycle Manager patches a host, it can automatically use vMotion to move all the running VMs off that host onto other hosts in the cluster.
Evacuate the host first.
Right. Then it applies the updates to the empty host, reboots it if necessary, and then lets VMs move back onto it. So for your applications running inside those VMs, there's often minimal or even zero perceived downtime. It really streamlines host patching and upgrades, making maintenance much less painful.
That is smooth. Okay, finally, with all these complex pieces working together, hosts, VMs, networks, storage, HA, DRS, how do you actually keep an eye on everything? Make sure it's all performing well, maybe predict issues, spot problems before they become critical. You almost need a crystal ball for your infrastructure.
Hey, yeah, a crystal ball would be nice. But the next best thing is proactive management and intelligent analytics. And that's where VMware ARIA Operations comes in. You might know it by its older name, vRealize Operations or VRApps.
ARIA operations, okay.
This is the crucial tool for that visibility. It provides really intelligent performance monitoring and capacity planning. It pulls in a huge amount of data, metrics from your VMs, hosts, clusters, CPU, memory, storage usage, network activity, latency, you name it.
So it collects everything, but what does it do with it?
That's the key. It analyzes all that data to detect performance issues, help pinpoint root causes, and even predict future needs. Like, hey, based on current trends, this cluster is going to run out of memory in 3 months.
Predictive. That's powerful.
Very. It's not just reporting what is happening right now, but helping you understand why and what's likely to happen next. It helps you optimize resource usage, troubleshoot faster, and avoid problems proactively. So less of a crystal ball, maybe more like a sophisticated diagnostic and predictive engine for your entire virtual environment.
As technology just keeps evolving at this insane pace, trends like edge computing, serverless containers everywhere, how might these foundational vSphere capabilities we talked about today adapt, or maybe even merge with these newer paradigms?
Interesting question.
Will those core principles of virtualization management, centralized control, high availability, resource optimization, will they stay constant even as the tech underneath shifts? What new challenges, what new opportunities are going to arise for managing these incredibly dynamic, interconnected systems of the future?
Yeah, what does vSphere look like in 5-10 years?
Exactly. We encourage you to keep exploring, keep questioning, and as always, keep diving deep.